Hi, my name is Don Briggs and I'm a member of the team at Breadboard Electronics. Before we get into our starter kit and all our projects, etc., it's worth spending a few minutes just looking at some of the symbols that will be portrayed in the circuit diagrams. If you've seen them all before, then you can just skip this video and move on, but for a complete novice this may be quite useful. All the diagrams are made up of very small symbols for batteries, resistors, capacitors and the like, and the idea is that you follow a path and you can actually build a circuit from that diagram without actually seeing the breadboard, just knowing what connects to what, and it makes life quite simple. But at first you've got to know what those symbols are. Now the obvious ones to start with are the power. We have a power symbol, which is positive one end and negative the other end, or ground the other end. Or we could just have a ground terminal, or we could have what we call power rails, where you show the voltage on one and the ground on the other. Simple as that. This bit here would be the same as this one here, and this part of the rail will be the same as this part of the battery here. Quite straightforward. But it pays to know what they are when you're looking at them. Now, resistors. We use a number of resistors in our circuits. I think in the starter kit there are actually 13 different values, and the idea of having 13 rather than 100 of them is to make it easier for you to find what you've got and to store them, etc. Now, there are different symbols for resistors, and the first one is the standard fixed value resistor. These are the common ones. Like I say, you've got 13 different ones of those in your kit. Now they're all color coded. On the internet you could find what these color codes mean, but because I've got bit dodgy eyesight really, I find it easier just to put the resistor on a multimeter just to give me an idea of what that resistance is. When you're testing them on a multimeter, make sure you're not actually touching both terminals of the resistor at the same time, because that will give you a misleading reading, especially with higher resistances. Now the second one and third one, these two are basically trimmers or potentiometers, are variable resistors. They look different, but technically they are very similar. This has an in and an out, if you like, either end, doesn't matter which, where this has an in and then two outs, if you like. Now from end to end of here will be the full resistance of that trimmer. Now the bit in the circuit you normally use is this pin here, so you go in one and come out the other, or go in one and come out the other. One of these two could even be joined together, so that there's always some kind of resistance within the circuit. Now if you think about this one, there's only two wires. Now the way to look at that, or the way to think about that, is that one of them's this wire and one of them's this wire, and it is as simple as that. You don't have to delve into it any deeper than that. They have each trimmer has a value from start to finish. If you want to test that value, put your multimeter on the two outer pins, the left and right pins of the trimmer, then that will give you the maximum value of the trimmer. If you want to see what the sweep values are, put it on one of the outer pins and the middle pin, and then turn it and look at the reading on your multimeter. LDRs and thermistors are also resistors, and they change their resistance based on the amount of light available and the temperature that's there, and that's all they do. They just change their resistance. So we add those into a circuit, normally with a trimmer to help fine-tune them and that sort of thing. Capacitors. We only have two types of capacitor that we use in our starter kit. They are the ceramic ones, which are polarity agnostic, and the electrolytic, which has a positive side to it. Now, the diagrams always show a positive side or positive wire, whereas the actual physical component shows the negative side, which is a bit confusing, but the point is that they have to go the right way around. So in a circuit you'll always have one side a bit more positive than the other. That's where the plus sign goes in the circuit. But with the physical component, you'll have the negative pin, which we'll come on to later. You'll have the negative pin, which will go towards the negative side of the circuit. It sounds a bit confusing. I don't know why the circuit diagrams are done like that, but they just are. Transistors. We only use 2 transistors in our starter kit, which is an NPN and a PNP. Just 2 different, very, very similar but different types of transistor. They both look identical, and you'll probably need a magnifying glass, or in my case a microscope, to see which one's which, because the writing is very, very small. But when you look at the flat side facing you, the pin outs are pin 1 collector, pin 2 base, pin 3 emitter, from left to right. So that's emitter base collector, emitter base collector. It's always the same on these 2 particular transistors. LEDs and diodes. Before I go any further, an LED is a diode. So a diode will only allow current to go through in one direction. So an LED and a diode must go in the circuit in the correct way round. Now, this bar here, same as this bar, denotes that goes towards the negative side of the circuit. A bit like I was saying with the capacitors just now, they got to go the right way round. So that goes to the negative side of the circuit. An LED will just be denoted by a couple of arrows, where a light dependent resistor, the arrows will be coming towards it. So yeah, just to give you an idea of what it's really doing. Now, if you plug these in the wrong way round, the chances are you won't damage them, but they will not allow current to go through. So they will block current. Therefore, if in the case of an LED, it will not light. So they must be the right way round. Integrated circuits. Now we have 3 integrated circuits in our starter kit, which is a 555 timer, an op amp, and a decade counter. You'll get used to them, and you'll get used to seeing the circuits, etc. But one thing I will point out is, like this statement down here, the pins are displayed for ease of circuit diagram, not the actual building. I will explain the pin order in a moment, but for now, just think the pins are in the order on the diagram to suit the diagram, rather than the building. It's just to make the diagrams look easier to read, a lot tidier. If they had the pins in the correct order, then the diagram would just look very, very messy and very, very complex. Just confuse the hell out of everybody. Now, this is how we will show our breadboard representations. Obviously none of these components are actually connected to anything, so it's not going to do anything. So at the top we have our standard battery pack. We have a 6-volt one here and a 9-volt battery there. All our circuits run off of 6-volt, which is why we supply a 4 battery pack, which is pretty much the same as this one. There's not much more we can say about that. Everybody knows what a battery looks like, so that's quite self-explanatory really. Resistors. This is our fixed type resistor. As you see, there's colour codes on there. Like I say, I always use a test meter to test them, because it's just quicker than trying to decipher the colours. It's a good learning curve to actually work out what colours mean what in what position, but to get it accurate, you might just as well use a multimeter anyway. And if you've got lots of them lying around on your desk after building a couple of projects, it is definitely an awful lot quicker. The one in the middle here is a Bourne type trimmer, and at the end there's a little tiny screw. Now that screw will allow you to turn and turn and turn and turn and turn before you get from one end of the spectrum to the other. They are good for fine tuning, but they can be a bit cumbersome when you're trying to just do something fairly quickly. Whereas the one next to it, the 3-pin, again it's a 3-pin trimmer, it will only go from, with a screwdriver, from left to right. It's as simple as that. You'll get your full value of the trimmer by looking at that pin, and the variable from one of the outer pins to the middle pin. Again, you just put it on a multimeter and that'll explain that. Capacitors, we have 2 types of capacitors. We only use one ceramic one in our kit. Most of them are actually electrolytics. Now, as we were saying with the on the circuit diagram just now about positive and negative, on the representation we have here, we have a little black mark, which denotes that it's that's the negative pin. Now, all capacitors will have some way of marking what that negative pin is. On the components that are in our starter kit, they've all got they're all black cased anyway, and they've all got a grey line down alongside the negative pin, so you can't really get it wrong. But again, they do need to be the right way round, otherwise they're just not going to work. 2 sensors, we have the LDR, looks a bit like that, and the thermistor, which looks nothing like that. Again, like I said before, they are actually resistors, and they will change the resistance within the circuit, so the circuit needs to be built around the resistance that of their range. LEDs and diodes, this is how we represent them in our circuit. Again, can't really see it on here very well, but there is a flat edge to those, and that flat edge goes towards negative. Now, the physical diode, you have a long pin and a shorter pin. Now, the long pin goes to positive, just to confuse you. But you also find that LEDs, if you actually cut the leads on an LED and they're both the same, the LEDs themselves do have a flat edge. Now, that flat edge will be the negative pin. Again, if they're in the circuit the wrong way round, they just won't light up. So if you have an LED that does not light, turn it round, and that might be your problem. It might not, but it might be. Diodes, we've got a couple of diodes in our starter kit, and one of them looks a bit like this and the other one tends not to, but they are just general purpose diodes, and you can use them anywhere and interchange them at will. But again, they have a mark on one end, which is the negative end, to follow with the negative on the LEDs. Again, they will allow current to go in one direction and one direction only, so if your circuit's not working and you have a diode in it, try checking or turning it round to make sure it is right. Transistors. Our transistors do look a bit like this. We've only got 2 of them, very, very common general purpose transistors at the moment. And the flat side is the bit with the writing on. Now, if you hold that facing you, flat side facing you, the pins are like this: left emitter, center is the base, and the right is the collector. That will match up with the circuit diagram, and you will get used to which is which. The emitter on the circuit diagram is the one with the arrow on. Whether it's an NPN or PNP, it will always have the little arrow on, and the base is the one that joins the 2 outer ones together. Integrated circuits. Like I said before, we only use 3 in our starter kit just to get you going, just to get you interested, that sort of thing. But to actually work out what pins what, it is quite straightforward. It might look a bit weird when you first look at them, but they are all pretty much the same. At one end you will have a notch or a mark, or even both, or you may have a mark just denoting where pin 1 is. Now, if you hold them up the way that they are in this diagram with the notch or the mark at the top, pin 1 is on the left, top left. Then it's pin 2, pin 3, pin 4, pin 5, round the bottom, pin 9, pin 10, whatever. It goes in anti-clockwise until you get to the last pin, and they are all done that way. So they're very easy to work out. Right, that's the end of our basics from the electronic point of view. The next bit of this video will be the physical components themselves. Thank you for watching.
Hi, in this section of the video I'm going to try and show you the contents of the starter kit and try to explain the physical components themselves. First off, we have the resistors. There's 13 different types of resistors, and they all come on their little ammo strip like that. At the moment, yes, you can see them all nice and clearly. You can see the colours, you can probably work out what they are, but like I said before, when you've got a pile of these on your workshop bench or your kitchen table or whatever you're working on, you will find that it's quicker to actually test these on a multimeter rather than trying to work out what colours what. Like I say, there's 13 different values there. They're on their strips at the moment, but once you start playing with them, they'll soon be off of their strip and you won't know what they are. Next we have the trimmers. We have a few different types. These ones here are the Bourne ones with the tiny little screw on the end. Like I say, they wind down, so they're more used for fine tuning than quick tuning, whereas this type it'll only sweep from one side around to the other, so it's a very quick go from nothing to the maximum. And that one is just another version of that one. They're just different types. What we haven't talked about before are switches. We have four little switches in our kit. This is a push to make, push to break, which means it latches on. Unfortunately, a bit of a design fault here. The pins on here don't 100% marry up with the holes on the breadboard. So what you'd have to do is just to bend them out very, very slightly, and then it'll be okay. All the others just fit on the breadboard as per normal. And you have momentary switches. This one's a little slide switch that we're probably used to seeing. This little thing here is a buzzer. It's just a little noisy thing that we have one or two circuits to say what it is, and that's included in the kit also. Here we have the thermistor. It's just got like a little black bead on the top, like it's been dipped in chocolate or something. That's your thermistor, and I've got a magnetic screwdriver, which is not good. And this is your LDR. Let me try and pick one of those up and show the camera. That's an LDR. Like I say, it looks very, very similar to it does in the breadboard representation that we've seen before. Now, I left this one here on purpose. It has a bent pin. A lot of these have bent pins. Now, don't worry about it, just straighten them up. You just got to check them first, but just straighten them up and they will be fine. They get bent in transit, handling and whatever, so it's not a major problem. They're not second hand, that I can assure you. These two little things here are the diodes. Again, they're both up the same way, but there's a little black line along one end. That is your negative. So that's something to always look for on a diode, is that little black line or a white line, a grey line, something that just denotes one end is different from the other. Over here we have our little pile of LEDs. As you can see, one pin is longer than the other. Now, this is where I'm going to muck up the light. That pin, that long pin, goes towards the positive side of your circuit, but if you cut them off and something goes awry, like they're both the same length, you'll find there's a flat edge on one side of the LED. It's not that obvious, but there is a flat edge, and that flat edge will be alongside the negative pin. So it's a bit confusing, but that's the way they are. That's LEDs. Now, you might have a bit of camera shake here because I'm running out of desk. This pile is the electrolytic capacitors. Now, like I said in previous video, they have a grey stripe down, these particular ones, and that denotes the negative side. So when you have the positive on the circuit diagram, you just have the negative side on here. These little things here, they are actually the ceramic ones, which can get plugged in either way. Transistors, we have our, it makes no difference to you watching this, but that's an NPN and that's a PNP. I don't know if you can see it very clearly or if at all in the video, but there is actually writing on that flat edge, and the pins on the facing the flat edge go emitter, base, collector, emitter, base, collector. Just trying to remember that. Now our ICs, we have a couple of 555 timers, because you will use those quite a lot. We have an op amp and a 4017 decade counter. That is what you'll need for 40 plus video presentations that we've got in our starter kit. And when we have our extras kit, there will be a few extra bits and pieces, but the idea is behind the starter kit is to give you enough items to play with, make lots of circuits and whatever. But if you get bored, you haven't wasted lots of money. That is the point. It's not for everyone. Some people like the idea of doing it and then they lose interest, or life gets in the way and they can't get back to it, but at least that way they don't waste too much money in the process. Now if you want to extend your knowledge, extend your kit, then obviously there's lots of ways of getting the extra bits, but we will always add extra components based on what our videos are actually portraying. Right, that's it for the component side of the presentation. Thank you very much for watching. Sorry about the camera shake.